Determine equipment reliability expectations. Assessing and assuring equipment reliability are two key activities in this area. It begins with evaluating equipment performance metrics like reliability, availability, maintainability, and criticality to understand how well assets perform and where they might fail. The aim is to quantify asset behavior and predict failures before they occur. Once assessment is complete, the focus shifts to assuring reliability. This means implementing the right maintenance strategies, e.g., preventive, predictive, RCM, CBM, that match the criticality and failure modes of each asset. The goal is to maintain equipment performance, reduce downtime, and do so at the optimal lifecycle cost. It's important to align equipment reliability goals with the broader business objectives, regulatory codes, plant processes, and stakeholder expectations. This ensures that reliability efforts support profitability, safety, compliance, and operational efficiency. Reliability expectations should be developed using RAMs, reliability, availability, maintainability, safety, a framework to determine how equipment meets performance and safety needs over time. Risk-based approaches, factoring in consequences of failure, including safety, environmental impact, operational cost, and regulatory compliance. Asset criticality, setting higher expectations and tighter controls for assets whose failure would have significant business or safety consequences. Evaluate equipment reliability and identify improvement opportunities. To ensure optimal asset performance, it's essential to evaluate current equipment reliability by comparing actual performance data like MTBF, MTTR failure rates against expected reliability standards. This helps determine whether assets are underperforming. Identify gaps by analyzing failure history, conducting benchmarking against industry peers, and applying statistical tools such as Weibull analysis for failure prediction and root cause failure analysis, RCFA, to uncover underlying causes. These techniques help prioritize assets for improvement. Once gaps are identified, review current workflows and maintenance practices to find inefficiencies or misalignments. Implement data-driven improvement actions such as refining PM tasks, increasing CBM coverage, or enhancing technician skills. Continuous monitoring ensures the reliability performance moves toward the desired targets. Establish a strategic plan to assure reliability of existing equipment. To maintain long-term performance, develop a customized maintenance strategy based on asset condition, criticality, and history. This includes preventive maintenance, PM, for time-based tasks, condition-based maintenance, CBM, using sensor or inspection data, autonomous maintenance by operators, restorative maintenance for worn-out parts or degraded functions. Also, conduct risk identification and mitigation through tools like FMICA, failure modes, effects, and criticality analysis, to assess potential failure impacts. RCM, reliability-centered maintenance, for developing focused maintenance strategies. Precision maintenance techniques to ensure tasks are done to exact specifications, improving reliability. Prioritize high-risk, high-cost, or production-critical assets to ensure the plan delivers maximum impact. Establish a strategic plan to assure reliability of new equipment. Ensure reliability is embedded from the design and procurement stage by specifying reliability and maintainability requirements in RFQs and equipment specs. During commissioning, verify compliance using acceptance testing. Use lifecycle cost (LCC) analysis to evaluate total ownership costs, purchase, maintenance, downtime, plus disposal, and choose vendors with a track record of reliable equipment. Qualify suppliers through technical and reliability performance reviews. Integrate preventive, condition-based, and autonomous maintenance planning at the design stage, ensuring the right maintenance model is in place from day one. This proactive approach reduces future failures and ensures long-term asset reliability. Justify the costs of selected plans for implementation. To gain management approval and funding, it's essential to develop a solid business case that outlines the financial and operational benefits of implementing reliability plans. Use cost-benefit analysis to compare the investment cost against potential savings and performance improvements. Support the justification using metrics like OEE, Overall equipment effectiveness to show productivity gains, MTBF, mean time between failures, to show reliability improvements, cost of unreliability, including downtime and quality losses, safety risk reduction, and ROI, return on investment. To evaluate financial viability, apply economic tools like DCF, discounted cash flow, to assess future value of investments, NPV, net present value, to measure profitability, and hurdle rate, to compare expected return against minimum acceptable return. Use Pareto analysis to focus efforts on high-cost, high-impact assets that contribute most to downtime or maintenance costs. Implement selected plans to assure equipment reliability. Once approved, reliability plans should be aligned with operations, maintenance, and organizational goals to ensure seamless execution. Utilize tools such as CMMS, Computerized Maintenance Management System, for task scheduling and documentation, PDM, predictive maintenance, and sensor data analytics for condition monitoring, failure prediction tools for proactive maintenance planning. Support implementation by ensuring detailed procedures are in place, workforce is trained and competent, communication flows effectively, and organizational structure supports accountability. Continuous monitoring through work orders, KPIs, and skills assessments ensures feedback is collected for refinement and improvement. Review reliability of equipment and adjust reliability strategy. Regularly assess actual equipment performance against reliability targets using dashboards and key performance indicators, KPIs. Identify gaps by performing root cause analysis, RCA, on underperforming assets, internal and external benchmarking to measure competitiveness. Based on insights, implement corrective actions to address deficiencies. Use the PDCA, Plan, Do, Check Act, cycle to ensure continuous improvement of strategies and processes. Track adjustments in both strategic and tactical plans, and report outcomes to stakeholders for transparency and future learning. This iterative process keeps reliability initiatives aligned with business needs. Justify the